The paper delves into the advancements in recommender systems, encompassing data, algorithms, and evaluation aspects. It presents a comprehensive analysis based on a systematic review of 286 research papers. The study identifies 5 major research topics: algorithmic improvement, domain applications, user behavior and cognition, data processing and modeling, and social impact and ethics. It highlights the limitations of current RSs, including data-related issues like cold start and data sparsity, algorithmic issues such as interest drift, and evaluation issues like offline data leakage. To address these challenges, the paper suggests several solutions, including the use of physiological signals for multimodal modeling, defending against data poisoning, and fine-tuning pre-trained large models for device cloud resource scheduling. These advancements aim to enhance the performance and reliability of recommender systems, ultimately improving user experience and satisfaction. The paper delves into the current landscape of recommendation systems, RSs, research, emphasizing the challenges posed by emerging technologies, diverse user needs, and novel scenarios. It underscores the potential of technologies like generative AI, while also highlighting the imperative of addressing privacy and ethical concerns. The expansion of RS applications into new domains, such as the Internet of Things and Metaverse, is noted, along with the complexity of user interactions and data integration. The paper stresses the importance of RSs being not only accurate but also socially responsible and sustainable. It identifies gaps in existing reviews, particularly in the comprehensive evaluation of RSs across data, algorithms, and evaluation amid new technologies and diverse needs. The study aims to address these gaps through a systematic review of 286 research papers, focusing on the severe challenges faced by RSs in terms of data, algorithms, and evaluation. This systematic review adheres to the PRISMA guidelines, aiming to provide a comprehensive analysis of recommender systems, RSs, based on data, algorithms, and evaluation. The literature search was conducted using predefined keywords in multiple databases, including Web of Science, ScienceDirect, and SpringerLink, as well as gray literature sources like arXiv and Google Scholar. A total of 6,780 papers were identified, with duplicates, papers lacking full text, non-research articles, and irrelevant papers excluded, resulting in 286 papers selected for further analysis. The exclusion criteria included duplication, missing basic information, lacking full text, non-research articles, and papers unrelated to RSs. Papers with methodological irregularities, such as unreliable research designs or experimental setups, were also excluded. The systematic review approach ensures transparency, replicability, and reliability, providing a comprehensive analysis of RSs based on the selected literature. The PRISMA guidelines provide a structured framework for conducting the review, ensuring scientific rigor and reliability. The paper conducts a systematic review on the state-of-the-art in recommendation systems, highlighting key issues such as a lack of transparency in algorithm development, insufficient data sharing, and the use of outdated control algorithms. A bibliometric analysis reveals that most RS research originates from Asia, with China being the most prolific country. RSs are predominantly applied in entertainment, health, and internet, e-commerce domains. 5 hot research topics identified are algorithm improvements, domain applications, user behavior, cognition, data processing, modeling, and social impact, ethics. The paper emphasizes the need for transparent and collaborative research practices and calls for further investigation into RSs, particularly in underexplored domains like tourism and pest detection. The distribution of core technologies in recommender systems is a key area of focus, encompassing 5 categories: collaborative filtering, content-based recommendation, knowledge-based recommendation, hybrid recommendation, and context-aware recommendation. Collaborative filtering is the most studied, with model-based and memory-based approaches. Hybrid recommendation strategies, integrating various technologies, have also garnered significant interest. Content-based recommendations leverage multi-source and multimodal item data, while context-aware recommendations integrate contextual information. Knowledge-based recommendations utilize domain knowledge and user profiles. The challenges in RS research, particularly data problems such as cold start, data sparsity, and data poisoning, are also highlighted. In recommendation systems, data quality is crucial for accurate and reliable recommendations. However, challenges like cold start and data sparsity often lead to inadequate user experiences. To address this, researchers have proposed integrating multimodal information, such as images, text, and audio, to enrich historical interactions and enhance predictive capabilities. Additionally, incorporating social network data and sensor information can provide contextual cues for user behavior, improving recommendation systems' applicability. Traditional modal data, however, are static and fail to capture real-time and interactive user needs. The emergence of new technologies, such as brain-computer interfaces and mixed reality, is revolutionizing how users acquire information and interact. This necessitates exploring novel methods for capturing user behaviors and preferences. For instance, brain-computer interfaces can provide real-time neural responses, while mixed reality can offer immersive and interactive experiences. To harness these advancements, researchers must develop innovative data capture and integration techniques. This includes designing multimodal fusion models that can effectively combine diverse data sources, such as neural signals, sensor data, and social network information. Furthermore, developing adaptive and context-aware recommendation algorithms is crucial for providing personalized and timely recommendations. By addressing the limitations of traditional data sources and integrating novel data capture methods, recommendation systems can better cater to dynamic and interactive user needs. This paradigm shift has the potential to significantly enhance user experience and provide more accurate and reliable recommendations. Algorithms are crucial components of recommender systems, significantly impacting service performance. The selection, design, and optimization of algorithms become increasingly important as data scales and application scenarios expand. This study analyzes 12 types of algorithmic challenges, categorized into two primary classifications: low performance and low accuracy. Low performance encompasses cross-domain adaptive, device-cloud collaboration, multitask conflicts, and environmental awareness. For instance, cross-domain adaptive algorithms address users' interests migrating between different domains. Low accuracy includes lack of accuracy in recommendations, interest drift, non-causal drivers, uninterpretable recommendations, algorithmic black box, algorithmic discrimination, information cocoon, and privacy security. Interest drift is a significant challenge, as users' interests, behaviors, and needs change over time. Traditional recommender systems often underperform due to flaws in model design and data distribution. They rely on fixed rules or pattern matching, limiting their ability to generate diverse new content in real time and meet diverse user needs. Generative recommendation offers a promising new paradigm to address these challenges, focusing on interpretability, recommendation effectiveness, content generation quality, and diversity. However, practical applications still face numerous challenges, including limited consideration for diverse experimental contexts, unexplored application scenarios, and unsolved issues in applying generative recommendation across different domains and user groups. Researchers in recommender systems often focus on optimizing a single metric, neglecting other crucial aspects such as satisfaction, cost, and social impact. To address this, novel approaches are required to design, evaluate, and optimize generative recommendations that meet multiple metrics. Device-cloud collaboration is a key area of research, involving coordinating small device-side models and large cloud-side models. This collaboration can be categorized into three areas: device-side inference, device-side learning, and device-cloud scheduling. Device-cloud scheduling optimizes resource utilization and recommendation efficiency by coordinating computing tasks between cloud and device, facing challenges such as efficient mechanisms to cope with growing computational demands and adaptive machine learning. Another area of research is non-causal drivers, which rely on modeling correlations using user historical behavior or user item features to link high-value content with user needs. However, correlations do not imply causation, compromising fairness, interpretability, and generalization of recommendations. Causal inference is used to model and infer causal relationships in RSs, exploring adjusting causal relationships through front door or backdoor methods. Multitask conflicts are becoming increasingly important, as RSs need to handle multiple recommendation tasks simultaneously. Multitask learning enables recommendation models to learn multiple tasks simultaneously within a unified framework, improving overall task effectiveness by sharing underlying representations. In the context of multitask learning for recommender systems, designing effective model structures and training strategies is crucial to balance the mutual influence and interference between tasks. Moreover, ensuring the model's generalization to new tasks and scalability are major challenges. Evaluation is a critical component of recommender systems, as it determines the effectiveness of recommendation services. A comprehensive evaluation system assesses performance effectively, guides algorithm optimization, reflects real user needs, and enhances user stickiness. However, only a limited number of papers, 15 out of 286, focus on RS evaluation, addressing two primary issues: offline data leakage and multi-objective balancing. Offline data leakage occurs when using future information not available during offline training, which can lead to biased evaluation results. Common methods for partitioning training in test sets, such as random partitioning, leave one out partitioning, and time-based partitioning, are vulnerable to offline data leakage. For instance, leave one out partitioning may inadvertently include future interactions from user V in the preceding interactions of user U. While some studies attempt to build time-aware RSs using timestamps of training instances, challenges remain, particularly with emerging technologies like pre-trained large language models or generative AI, which demand larger data scales and increase data leakage risks. Multi-objective balancing is another critical issue in RS evaluation, as traditional metrics like precision, mean absolute error, and normalized discounted cumulative gain are insufficient to capture the value of recommendations. The focus has shifted to beyond accuracy metrics, such as diversity, novelty, and content safety, which are essential for providing engaging recommendations. Studies are exploring new methods to optimize comprehensive performance by balancing accuracy with these beyond accuracy metrics. Despite these advancements, challenges persist, particularly with new algorithms, scenarios, or diverse user demands, requiring adjustments and new metrics. Finally, the paper highlights the need for future research implications, as new technologies, emerging scenarios, and diverse user demands present significant opportunities for RSs but also challenge traditional RS data, algorithms, and evaluation methods. The paper emphasizes the pressing need for researchers to address the limitations and potential extensions of existing recommendation system, RS, research, particularly in light of new trends. Key trends in RS research topics and recommendation technologies are highlighted, including algorithm improvements, domain applications, data processing and modeling, user behavior and cognition, and social impact and ethics. The study also underscores the importance of integrating physiological signals with traditional modal data to enhance the real-time responsiveness, interactivity, and intelligence of RSs. This can be achieved through the use of wearable devices and smart sensors, which provide immediate feedback reflecting users' deeper emotional states, cognitive characteristics, and focus of attention. In the realm of recommender systems, a critical challenge emerges in the form of data poisoning. This malicious technique aims to manipulate the system's recommendations by introducing false or misleading data. To combat this threat, it is essential to understand and model user information behavior. One effective approach is the berry-picking behavior model, which leverages deep learning to simulate users' dynamic behavior in information retrieval logs. This model enables the design of sophisticated data poisoning detection systems that can identify and mitigate such attacks. From an algorithmic perspective, social experiments play a crucial role in evaluating generative recommendations in real-world scenarios. These experiments can explore the applicability and effectiveness of generative recommendations across different contexts, providing valuable insights into user acceptance, satisfaction, and concerns about privacy and data security. By understanding user behaviors and developing advanced algorithms, researchers can create more resilient and adaptive recommender systems that better serve users while mitigating the risks associated with data poisoning. This ongoing research aims to enhance the reliability and trustworthiness of these systems, ultimately improving the user experience and fostering a safer digital environment. Evaluating the effectiveness of generative recommendation systems through controlled field experiments is crucial for understanding their applicability and performance differences compared to traditional recommendations across various contexts. The research framework outlines the stages involved, including real scenario applications and multidimensional scientific measurements, as depicted in Fig. 5. A key finding is the importance of fine-tuning pre-trained large models for scheduling device cloud resources, which can be achieved through strategies such as device-side inference, device-side learning, and device cloud scheduling. This fine-tuning enables the development of lightweight universal schedulers that can efficiently handle real-time recommendation tasks while balancing personalized recommendations with system performance. The study highlights the need for adapting to specific computing resources and user demands, exemplified by the example of large language models like ChatGPT. Distributed inference and distillation techniques are proposed as solutions to address these challenges. By exploring the strengths and limitations of generative recommendation systems, this research provides insights into their potential applications and areas for future improvement. The importance of causal inference in recommender systems is emphasized, moving beyond correlations to understand causal relationships. A research framework combining deep reinforcement learning is presented, focusing on challenges like poor causal discovery capabilities and the need for flexibility. The concept of actor-critic reinforcement learning is introduced, where the transformer serves as the actor network, handling high-dimensional feature representations of causal relationships in user behavior policies. The critic network evaluates these actions based on the environment state and reward signals, updating recommendation strategies through interactive learning. This framework aims to optimize decision strategies to handle complex causality and uncertainty in the recommendation process. Current recommendation systems face significant limitations in balancing competing factors, optimizing collaboration, and mitigating recommendation conflicts. To address these challenges, a composite function can be designed to learn from the overall distribution of relevance judgments, effectively coordinating multiple recommendation tasks. Multitask learning offers a promising solution, particularly when leveraging probability distribution loss functions, such as Kullback-Leibler divergence, to fully exploit information from ranking models. This approach enables the system to capture complex relationships between tasks and improve overall performance. A crucial aspect of recommendation systems is evaluation, which requires a multifaceted approach. Customization is key, achieved through cross-temporal strategies that partition datasets to reflect diverse user behaviors and preferences. A comprehensive evaluation framework is essential, assessing recommendation objectives throughout the system's lifecycle. Superaccuracy metrics, such as novelty and content safety, are critical in addition to traditional accuracy metrics. Balancing these metrics across different scenarios, tasks, and users is crucial to ensure a fair and effective recommendation system. By adopting a holistic approach that integrates multitask learning, customized evaluation, and superaccuracy metrics, next-generation recommendation systems can better navigate the complexities of real-world applications. Evaluating recommender systems, RSs, is a complex task that depends on various factors, including specific points in time, data updates, changes in user behavior, and technological evolution. To provide a comprehensive understanding of RS performance, it's essential to evaluate them at different lifecycle stages, aiding decision-making. A novel training set and testing set splitting strategy is proposed, which involves splitting data into training instances and testing instances across local and global temporal dimensions. This approach enables incremental RS algorithm models to adapt to changes over time. A multidimensional and multi-perspective evaluation framework for RSs is presented, considering 4 contextual dimensions: recommendation scenarios, task types, experiment types, and target groups. The framework assesses RS performance at different lifecycle stages, including requirement analysis, system design, coding and implementation, system testing, deployment and delivery, and operation and maintenance. The evaluation framework examines various aspects of RS performance, including requirement completeness and consistency, functionality and module coupling, code readability and security, accuracy and precision, flexibility and response time, satisfaction and retention rate, and revenue. This comprehensive evaluation framework provides a more complete understanding of RS performance, enhancing user experience. RSs have become essential for alleviating user information and cognitive overload, but rapid technological advancements and diverse user needs present new challenges. This study systematically reviews key development challenges in 3 areas: data, algorithms, and evaluation, and proposes potential expansions to address these challenges. Systematic reviews of recommender systems, RS, are often limited by their reliance on a single language and database, overlooking valuable insights from diverse linguistic and cultural contexts. To address this limitation, future research should adopt a more comprehensive approach, incorporating multilanguage RS studies from additional databases. This expanded search scope would enable a more in-depth examination of cutting-edge RS technologies and innovations across various fields. The authors emphasize the importance of exploring beyond the confines of a single language and database, as this would facilitate a more nuanced understanding of RS applications and their potential impact. By retrieving and collecting studies from diverse sources, researchers can uncover novel approaches, methods, and applications that may have been overlooked in traditional, language-restricted searches. The significance of this approach lies in its potential to reveal previously unknown correlations, patterns, and insights that may be specific to particular languages, cultures, or regions. By broadening the search scope, researchers can develop more comprehensive and inclusive RS models, capable of catering to diverse user needs and preferences. The authors also provide essential information on author contributions, funding, and conflicts of interest, ensuring transparency and accountability in the research process. A comprehensive list of references is also included, facilitating further exploration and research in this critical area. Advancements in recommender systems have been shaped by significant contributions from various studies. Felfernig et al.'s 2019 work on recommender systems in the Internet of Things provides a comprehensive overview of the field. Meanwhile, Zhang et al.'s 2023 evaluation of fairness in large language model recommendations highlights the importance of fairness in these systems. A systematic review of healthcare recommender systems by Itamadi et al. 2023 underscores the potential of recommender systems in healthcare. The intersection of big data and metaverse is also explored, drawing on Sun et al.'s 2022 survey and Mystekidis's 2022 definition of metaverse. However, security and privacy issues in metaverse, as discussed by Xuguang et al. 2023, pose significant challenges. Furthermore, the gender fairness of recommendation algorithms in the music domain is investigated by Melchiorre et al. 2021, while Chen et al. 2022 discuss the potential drawbacks of artificial intelligence recommendations. Online course recommendation systems, privacy-preserving research, and explainable information recommendation are also reviewed, building on studies by Yu et al. 2023, Feng et al. 2023, and Li et al. 2023, respectively. Finally, a systematic review of trust-based recommendation systems in the Internet of Things by Mohammadi et al. 2019, and a discussion on the preferred reporting items for systematic reviews and meta-analyses, as outlined by Maher et al. 2009, and Liberati et al. 2009, provide further insights into the development of recommender systems. Recommender systems have been increasingly applied across various domains, including healthcare, agriculture, and social stratification. This review systematically analyzes recent studies, providing insights into the design and implementation of these systems. The importance of systematic reviews in the field of recommender systems is highlighted, citing studies by Pollack and Burge, 2018, and Ma and Wang, 2023. Publishing systematic quantitative literature reviews is particularly beneficial for early career researchers, as emphasized by Pickering and Byrne, 2014. In the healthcare domain, recommender systems have been applied to facilitate responsive engagement of senior adults in daily activities, as demonstrated by Kulev et al., 2020. De Kroon et al.'s 2021 systematic review on health recommender systems further underscores their potential. The design and simulation of precision marketing recommendation systems based on the NSSVD++ algorithm, as discussed by Liu and Zhang, 2023, has also been explored. Collaborative auto-encoders with knowledge distillation have been proposed for top-end recommender systems, as presented by Pan et al., 2019. Moreover, multitask recommendations with reinforcement learning have been investigated, as shown by Liu et al., 2023. Current metaverse applications in healthcare, surveyed by Bansal et al., 2022, have also been reviewed. In the tourism domain, intelligent recommendation models based on collaborative filtering and user profiling have been applied. This comprehensive review highlights the versatility and potential of recommender systems across various domains, emphasizing their design, implementation, and applications. Recommender systems have been extensively explored in recent literature, with a focus on data, algorithms, and evaluation. A thorough review of 16 research papers reveals diverse aspects of recommender systems, including data disclosure mechanisms, collaborative filtering, and hybrid approaches. For instance, simulation-based studies have investigated the impact of data disclosure mechanisms on recommender systems, while others have proposed novel algorithms, such as the three-way naive Bayesian collaborative filtering recommendation model for smart cities. Category-preferred canopy k-means-based collaborative filtering algorithms have been developed to improve user satisfaction, while multitask fusion via reinforcement learning and incorporating user rating credibility have also been explored. Hybrid approaches, including attentive representation learning and deep collaborative filtering, have shown promise, as have pattern-based hybrid book recommendation systems utilizing semantic relationships. Mainstream bias in recommender systems is a critical issue that must be addressed, and incorporating sentiment analysis from product reviews can enhance system performance. Proficient video recommendation frameworks have been developed using hybrid fuzzy Siemens clustering and Kullback-Leibler divergence algorithms. The reviewed papers demonstrate significant advancements in recommender systems, addressing various challenges and limitations. This comprehensive analysis provides a solid foundation for understanding the complexities of recommender systems and their applications in diverse domains, highlighting the importance of continued research and development in this field. Multitask learning has become a crucial component in modern recommender systems, enabling the simultaneous optimization of multiple objectives to improve recommendation accuracy. However, a significant challenge lies in reducing negative transfer, where the performance of one task degrades due to the introduction of another task. Recent research has proposed various techniques to address this issue, including feature decomposition, generative recommendation, chat-based interactive recommenders, and device cloud collaborative recommendation. Feature decomposition, as proposed by Zhou et al., involves decomposing features into task-specific and shared components to mitigate negative transfer. Wang et al.'s generative recommendation model, on the other hand, leverages generative adversarial networks to model complex user behaviors. Gao et al.'s chat-based interactive recommender system utilizes large language models to enhance user experience, while Yao et al.'s device cloud collaborative recommendation method optimizes resource utilization and improves recommendation accuracy. Deep learning algorithms have also been applied to multi-criteria recommender systems, as demonstrated by Chambord and Vu et al. Context-aware recommendation systems, such as Wang's PowerMat, solve the cold start problem without relying on user item rating values. The integration of knowledge graphs in recommendation systems, as shown by Wu et al.'s knowledge graph-based multi-context-aware recommendation algorithm, has also been explored. Furthermore, edge computing has been identified as a potential solution to enhance recommendation systems, as demonstrated by Gong et al.'s Edge Rec system. The paper highlights the importance of knowledge-based systems and edge computing in enhancing recommendation paradigms. It provides a comprehensive overview of the current state-of-the-art in multitask learning for recommender systems, emphasizing the need for novel approaches to address the challenges of negative transfer and cold start problems. Advancements in recommender systems have been driven by research in data, algorithms, and evaluation. Notably, studies have explored multitask feature and structure learning for user preference-based knowledge-aware recommendation, fusing context into knowledge graphs for common-sense question answering, and developing knowledge-based recommendation systems using semantic web rules. The impact of completeness of item content data on prediction accuracy has been investigated, alongside comprehensive surveys on multimodal recommender systems. Moreover, research has delved into multimodal representation learning for recommendation in the Internet of Things, convolutional neural network-based personalized program recommendation systems for smart television users, and ecological mechanisms of user information interaction in the metaverse environment. Robustness against attacks has been a significant focus, with studies on provably robust recommender systems against data poisoning attacks, shilling attack detection, and clustering-based supervised contrastive learning for identifying risk items on heterogeneous graphs. Furthermore, practical data poisoning attack frameworks against next item recommendations and stealthy textual backdoor attacks via black box generative modeled triggers have been explored. Finally, the section addresses the importance of building human values into recommender systems and introduces a large-scale multi-purpose benchmark dataset for recommender systems. This comprehensive analysis highlights the diverse range of advancements and challenges in the field, providing a solid foundation for future research and development. The authors present a comprehensive list of the key factors that contribute to the effectiveness of quantum error correction codes. This list includes code distance, error rates, qubit coherence times, and gate fidelity. The code distance refers to the minimum number of errors that must occur for the code to fail, while error rates describe the probability of an error occurring at each step of the computation. Qubit coherence times indicate how long quantum information can be maintained without loss, and gate fidelity represents the accuracy of quantum operations. These factors are crucial in assessing the reliability and efficiency of quantum error correction methods, which are essential for scalable quantum computing. In the realm of information technology, recommender systems play a pivotal role in enhancing user experience by suggesting personalized content. These systems are evaluated based on various objectives such as accuracy, user satisfaction, and novelty. However, achieving these objectives can be challenging due to factors like data sparsity, cold start problem, and scalability issues. One crucial aspect of evaluating these systems is understanding the importance of accuracy. High accuracy ensures that the recommendations provided are relevant to the user's preferences, thereby improving overall satisfaction. Moreover, multi-objective evaluation is essential as it considers not just one but several key performance indicators simultaneously. User evaluations also hold significant importance, particularly in urban recommender systems. These evaluations help in understanding user behavior and preferences, which can then be used to refine the recommendation algorithms. Furthermore, incorporating complex networks and deep learning techniques has shown promising results in EEG signal analysis, demonstrating their potential in enhancing the capabilities of recommender systems. Despite these advancements, there are still several challenges that need to be addressed. For instance, understanding the underlying mechanisms of these systems is crucial for developing more effective algorithms. Moreover, innovative solutions are required to overcome the limitations of current systems and ensure they continue to meet evolving user needs. In conclusion, recommender systems are an integral part of modern technology, and their evaluation, objectives, and challenges are multifaceted. By focusing on accuracy, incorporating user evaluations, and leveraging advanced technologies like complex networks and deep learning, we can create more efficient and personalized recommendation systems that cater to diverse user preferences. Alcaraz et al.'s paper delves into the user requirement analysis for a real-time NLP-based open information retrieval meeting assistant. The authors underscore the necessity of a system that can efficiently assist in meetings by providing relevant information. They propose a framework for user requirement analysis, focusing on meeting context, user roles, and information needs. This adaptable framework is designed to cater to various meeting scenarios and user types. The authors also discuss the challenges and limitations of their approach, including the need for continuous improvement and the requirement for a large dataset for training the NLP model.